Alright, we're in unit number 6 still, and we are going to cover gravitational potential energy in this particular section. So let's go ahead and run through the key concepts, run through the factors that actually affect gravitational potential energy, and then I'll give you the equation for it. We'll talk about something called the reference point that we need to understand, and then we'll do a real quick key concept with gravitational potential energy. So here it goes. There are three factors that affect the energy stored in an object due to its position inside a gravitational field. And those three factors are mass, gravity, and height. Think of it in this way, in terms of being able to think through those individually. Imagine that there's someone that you're really upset with, and you want to maybe inflict some damage on them. And so you're going to inflict that damage by dropping objects on them. So if I were to ask you what are the three factors that would affect how much damage you could inflict on them, some of those factors, or three of those factors, would be the three that we have listed. Mass, you would want to drop the heaviest thing, or the most massive thing that you could possibly find. So instead of dropping tennis balls on this particular individual, you'd want to maybe drop shot puts. In terms of gravity, instead of dropping the objects here on Earth, you want to go to Jupiter, where Jupiter's gravitational field is about 2.5 times that of Earth's. So it's going to have basically 2.5 times more effect or damage on that person. So mass, gravity, gravitational field, and then the height. So instead of just dropping the shot put a foot off of this particular individual's head, maybe you want to climb to the top of a tall building and drop it that way. So those are the factors. Kind of weird to think about it that way, but I think it helps you understand the concept. So those are the three factors that affect gravitational potential energy. Remember, we have all different kinds of potential energy. One of those is called gravitational potential energy. Alright, so here's how it usually works. If I've got three factors that affect that particular concept, then those three factors are going to be the are what's going to show up in my equation that describes that particular idea, in this case gravitational potential energy. So gravitational potential energy, GPE, is equal to the mass of the object times the acceleration of gravity and times the height. And there is. And I would say if you've had a little bit of physics before, you at least have run across that particular equation. Let's run through the units just to justify the units and make sure that the units all work out. All right, mass is measured in kilograms. G is an acceleration of gravity, so that'll be meters per second squared, and in height it'll be measured in meters. So if I were to push all those together, meters times meters is going to give me meters squared. So I have a kilogram meters squared over second squared, and if you recall, a kilogram meter squared over second squared is the same thing as a joule. And so that makes sense because gravitational potential energy is energy. Energy must be measured in joules. So both sides are justified. So moving along, if we want to record a secondary record a second governing equation under energy on your units and constants sheet, that would be great. Here's the one that you want to include. So gravitational potential energy equals mgh, and I'll let you do that on your own. You can stop the video and do that. All right, the next point is a concept that's related to gravitational potential energy. We have to have this concept I guess understood before we're able to do problems with gravitational potential energy. And so let me give you the definition to reference point, and then we'll run through a couple key concepts, and then I think in the next video we'll actually do some practice ones. So here it is. Reference point is an arbitrary it's an arbitrary point, which means where you set the reference point. This will make sense a little bit more in the next video, but where you set the reference point is totally up to you. Now, usually the reference point is going to be the ground or the tabletop that you're using. But as we progress uh, throughout this chapter, we're going to find out that sometimes we want to actually move the reference point all the way out to infinity, an infinite distance from us. And so the placement of the reference point at the beginning is not too tough to figure out. As we move along through the chapter, we're going to find out that we're going to move it around a little bit, and the placement of the reference point will be important. But right now, it's arbitrary, and it will be arbitrary for the rest. I don't want to mislead you. It will always be arbitrary. Um, Usually, it's going to be right at the ground for now. All right, an arbitrary point is defined to have zero gravitational potential energy. So wherever you put the reference point, if it's on the ground, that's fine. Then if an object is on the ground, it has no gravitational potential energy. If you put the reference point on the top table, then this will have no gravitational potential energy. So generally, the ground, the reference level, unless otherwise. So, if they don't state it in a problem, tell you where the reference point is, yeah, it is arbitrary, but it's kind of custom that we just go ahead and say it's on the table, where it is like that, wherever you're working. All right, next, a little fun, a little more interesting. If the object, the reference point, so let's say that the reference point is a tabletop and the object is below then, well, what's the energy there? What's the gravitational potential energy? Well, here's how we work through that. If the object is below the reference point or the reference level, it's GP negative, and is considered to be in what's called energy well, which is analogous to being in an actual well because must be done to get the object out of the well. So don't make this too complicated, but basically if the object is below the reference point, we say that has negative energy. Remember, energy is a scalar. It's not a vector, so it doesn't necessarily give you direction. It's more of an indication of where the object is relative to the reference point. So if it's negative, it just means it's below the reference point. All right, the next question on the next page asks us this: true or false? An object can only have, an object can have only one form of energy at one time. Defend your answer with an example. So can an object have multiple forms of energy at the same time? And the answer is an emphatic true. That is a true statement. One is a baseball that's being thrown. A baseball that's being thrown can have kinetic energy because it's in motion, and also have gravitational potential energy because it's above the ground. Now we're assuming the reference level is going to be on the ground, so since you're above the ground, it'll have gravitational potential energy. There's a lot of other examples, but let's keep it simple for now. So the idea that we want to reinforce is the fact that an object can have more than one form of energy at any given time. It could have 3, it could have 4. In this case, I just gave it 2. So there it is, and we'll actually do an example with the equation in the next video.